I've learned the best meals are never in the restaurants everyone talks about. I spent 3 years chasing street food across Asia, and it taught me something. The places with plastic stools and no English menu, those are where you find the real thing. This spot doesn't have a website or a reservation system, but the broth has been simmering for 12 hours, and you can taste every minute of it. Sometimes the best experiences are the ones you stumble into, not the ones you plan. Imagine a classroom sharing one notebook. Every student owns a copy of that notebook. When someone writes new information, everyone updates together. Nobody can secretly change the notes. Blockchain works in a similar way. Transactions are added publicly. Every participant can verify the updates. This builds trust among strangers. Traditional systems need middlemen. Banks are examples of middlemen. Blockchain reduces dependence on middlemen. This can lower transaction costs. It can also increase speed. Blockchain transactions use cryptography. Cryptography protects information using mathematics. Secret keys are important in blockchain. Users receive public and private keys. A public key works like an address. A private key works like a password. People must protect their private keys. Losing a private key can mean losing access. Blockchain networks record all activities. These records are timestamped. Timestamping shows exactly when something happened. This improves accuracy and trust. Miners help verify blockchain transactions. Mining involves solving complex problems. Miners compete to confirm transactions. Successful miners receive rewards. Bitcoin mining uses large amounts of energy. Some newer blockchains use different methods. Proof of stake is one popular method. Proof of stake needs less energy. Validators replace miners in this system. Validators are chosen to confirm transactions. Blockchain systems can support smart contracts. Smart contracts are automatic digital agreements. They execute when conditions are met. Smart contracts remove manual processes. Ethereum helped popularize smart contracts. Developers build applications on Ethereum. These applications are called decentralized apps. Decentralized apps are also known as dApps. dApps operate without central control. Blockchain technology keeps evolving quickly. New blockchain projects appear every year. Some projects focus on finance, others focus on gaming or art. NFTs also use blockchain technology. NFTs represent ownership of digital items. Blockchain can store more than money. It can store identity information. It can also track products globally. The technology still has challenges. Understanding these ideas makes blockchain less confusing. Security is one major strength of blockchain. Hackers find blockchain difficult to manipulate. Each block depends on previous blocks. Changing one block affects the entire chain. And networks quickly notice suspicious changes. Blockchain uses distributed systems for protection. Distributed systems spread data across many computers. This prevents a single point of failure. Centralized systems are easier to attack. Blockchain reduces that risk. Transparency also improves confidence. The users can inspect public transactions. This creates accountability in the network. Some blockchains are public. Anyone can join public blockchains. Bitcoin is a public blockchain. Some blockchains are private. Private blockchains limit access. Businesses often use private blockchains. Hybrid blockchains combine both approaches. Blockchain technology supports digital currencies. Cryptocurrencies run on blockchain systems. Bitcoin is a cryptocurrency. Ethereum is another cryptocurrency network. Stablecoins are designed to reduce price swings. Volatility is a challenge in crypto markets. Prices can rise and fall quickly. Investors must understand the risks. Scams also exist in the blockchain world. People should research before investing. Wallets store blockchain assets. Digital wallets help manage cryptocurrencies. Hot wallets connect to the internet. Cold wallets stay offline for security. Offline storage reduces hacking risk. Blockchain can improve international payments. Cross-border transfers become faster. Fees can also become lower. Traditional transfers may take several days. Blockchain transfers can happen within minutes. Governments explore digital currencies too. Central bank digital currencies are being tested. These are called CBDCs. CBDCs are different from Bitcoin. Governments control CBDCs. Bitcoin remains decentralized. Blockchain can also help supply chains. Companies track products from factories to stores. Customers can verify product origins. This helps fight counterfeit goods. Healthcare systems may use blockchain records. Patients could control their medical data. Secure records can improve efficiency. Blockchain still requires further development. Understanding practical uses makes blockchain easier to appreciate. Learning blockchain becomes easier with real examples. Imagine sending money to a friend online. Traditional banks process the transaction. Banks verify balances and approvals. Blockchain networks can perform similar verification. The process happens without one central authority. Transactions enter the blockchain network. Nodes begin checking the transaction details. The network verifies whether the sender has funds. Valid transactions are grouped together. These groups groups form new blocks. The block gets added to the chain. Everyone in the network updates their copy. This process creates shared agreement. Blockchain records become nearly impossible to alter. Speed depends on the blockchain design. Some networks are faster than others. Scalability remains an important challenge. Scalability means handling many transactions efficiently. Popular networks sometimes become congested. Congestion can increase transaction fees. Developers continue improving blockchain performance. Layer 2 solutions help reduce congestion. These solutions work on top of blockchains. Lightning Network supports faster Bitcoin payments. Ethereum also uses scaling technologies. Blockchain communities often vote on upgrades. Governance is important in decentralized systems. Different communities make different decisions. Open source development drives innovation. Anyone can review blockchain code. This encourages transparency and collaboration. Smart contracts enable automated systems. Insurance claims could become automated. Rental agreements could run digitally. Voting systems may use blockchain someday. Secure voting could reduce fraud concerns. Education certificates can also use blockchain. Universities could issue digital diplomas. Employers could verify credentials instantly. Blockchain technology supports digital ownership. Artists use blockchain for NFTs. Gamers use blockchain for virtual assets. Virtual economies continue growing online. Environmental concerns still exist with some blockchains. Energy efficient systems are becoming more common. Public understanding of blockchain is increasing. Schools and universities now teach blockchain topics. Companies seek blockchain professionals. Blockchain careers continue expanding worldwide. Beginners should focus on core concepts first. Technical details can come later. Simple analogies help explain difficult ideas. Curiosity makes learning easier. Consistent practice improves blockchain understanding. Blockchain is more than just cryptocurrency. It represents a new way to share information. Trust is created through technology and consensus. Shared records improve transparency. Secure systems reduce manipulation risks. Blockchain combines computer science and mathematics. It also combines economics and networking. The technology continues evolving rapidly. New solutions appear every year. Businesses experiment with blockchain applications. They explore use cases from supply chains to finance.